Welcome to our tutorial on using IPFS with Ethereum. In today's video, we will explore how to harness the power of Interplanetary File System, or IPFS, to store data in a decentralized manner on the Ethereum blockchain. Before we dive into the code, let's briefly understand what IPFS is and its synergy with Ethereum. IPFS is a distributed file system that allows us to store and share files based on their content rather than their location, making it a perfect complement to Ethereum's decentralized nature. Now, why use IPFS with Ethereum? Storing large files directly on the Ethereum blockchain is inefficient and can lead to high transaction costs. By using IPFS, we can store our data off-chain and only save the hash of the data on Ethereum for verification purposes. In this video, we will set up an IPFS node, upload some files, and interact with these files through a smart contract on Ethereum. Let's start by installing the necessary packages. We need Node.js and npm for JavaScript development. After successfully installing the packages, we will create a project directory and initialize our Node.js application. Next, let's create a file named index.js where we will write our logic to interact with IPFS and Ethereum. In index.js, we will import our libraries and set up an IPFS client. We will use the HTTP API from IPFS hosted on Infura for our interactions. Now that we have our IPFS client set up, let's create a function called uploadFile to handle the file uploads. In the uploadFile function, we use the add method of the IPFS client to upload files. This will return an object that contains the path to our uploaded file, which is essentially a unique hash. Next, let's add some code to read a file from the local file system and upload it to IPFS. Let's create a file input for users to select a file. In the main function, we read a file from the local file system and then call our uploadFile function to upload it to IPFS. Remember to replace path / to / your /file.txt with your actual file path. Now that we can upload files to IPFS, let's move on to integrating with Ethereum. To do this, we need to set up a smart contract. Let's create a simple smart contract that can store the hash of our IPFS file. In our IPFS storage contract, we have a public string variable to store the IPFS hash and a function, setIPFSHash, that allows us to set the hash from our JavaScript code. Next, we need to compile and deploy our smart contract. For that, let's use the Sulk package to compile the Solidity code. In the compile contract function, we use the Solidity compiler to compile our smart contract. The compiled contract will give us the ABI and bytecode needed for deployment. Now, we will deploy the contract to Ethereum. Ensure you have the Ethereum wallet set up, and we will use ethers.js for interacting with the Ethereum blockchain. In the deploy contract function, we create a new instance of the contract factory and then deploy the contract. The deployed address will be printed to the console. With our smart contract deployed, it's time to store the IPFS hash on the blockchain. After uploading a file to IPFS, we can call our smart contracts function to store the hash. In the store hash on blockchain function, we create a contract instance and call the setIPFSHash function to store the hash. Make sure to replace contract address with the actual address of your deployed contract. Now let's put it all together in the main function. We will upload a file, get the IPFS hash, and store it on Ethereum. Now, when you run the index.js script, you should see the file uploaded to IPFS and the corresponding IPFS hash stored on Ethereum. This links your data to an immutable location that can be verified and accessed. As a recap, we successfully set up IPFS, uploaded files, created a simple smart contract, compiled and deployed it, and stored the IPFS hash on Ethereum. This demonstrates how you can leverage decentralized technologies to enhance your applications. Before we conclude, let's discuss some potential extensions. You could implement event listeners in your smart contract to notify your decentralized application when a new file has been uploaded. Furthermore, consider utilizing frameworks like Truffle or Hardhat to streamline your smart contract development and testing processes. They offer powerful suites that can help you build, test, and deploy your contracts more efficiently. Thank you for joining me in this comprehensive look at using IPFS with Ethereum. If you enjoyed the content, give us a thumbs up and subscribe for more tutorials on decentralized technologies. Check the links in the description for the source code and additional resources.